Going on page 57 when we're done. So yesterday we did the non-calculator part of this. Today we are doing the calculator part of this. And we are modeling exponential functions from data, which basically means we're writing equations from the data that they have given us. Okay. Right now we're talking about exponential models. And they can be constructed if we are given either the common ratio and the initial value. So the common ratio is B, your initial value is A. And your equation that goes along with that is y equals A times B to the x. So obviously, if they give you A and B, you substitute them in there and boom, you're done, right? Or if you have two input-output pairs, which basically means two ordered pairs, an x and a y. So instead of thinking of everything in terms of x and y, we talk about them as input and output, right? Those words are used a lot, so we got to make sure we understand how that works. So let's look at example 2 here. It says, for t being between 0 and 30 minutes, the number of fans inside a large sports stadium can be modeled by this exponential function. So here's the good thing about function modeling, is that they always give you the generic little equation that you need so you know what your goal is. Right? Do you know where to go, hon? Canvas assignments, the very top should be where you need to be. Okay. So they give you the generic one. Now, not with 2-1 and 2-2 when you're doing the sequences, they don't give you that. But for the functions that we're actually doing, they tell you exactly what we're looking for. Then it says F represents the number of fans inside the stadium, T minutes after the doors open. There are 47 people in the stadium 2 minutes after the doors open. And there are 2,602 fans 20 minutes after the doors open. Then it says, use the given data to write two equations that can be used to find the values for A and B in the expression for f of t. So that sentence there, it is telling me to write two equations. Does it say simplify the equations? No. Does it say find A and B? No. It literally just says write equations, okay? And like I told y'all yesterday, that's one thing that some people seem to have a hard time with, was writing equations and stopping last year. Something I felt like I was fighting against. So we have this big space here. I really should have put a second question, so we're just going to kind of put a line here so we can do a second part. But so we're going to look at this as the A part. I'll tell you what B part is when we get there. And so I need two equations. Now, they didn't give me A and B, so I can't just write one equation. Plus, it tells me I'm going to have to find them. So in order to do that, just like it said above, I need two input-output pairs, which means I need two ordered pairs. So in my information, they should have given me enough information to come up with two input-output pairs. Okay, so if I start here, it says there are 47 people in the stadium 2 minutes after the doors open. Is 47 the input or the output? It's the output, right? Because it says F is the number of fans, T is the time in minutes. So 47 is the output. The input for that would be 2. And then what's the input for my next ordered pair? 20. And my output? 2602, right? 2602. Should have made my parentheses bigger. Everybody okay with where everything came from? So I have my two input-output pairs, and I have what my equation is supposed to look like. So, and these input-output pairs, these are all T, F of T, right? I mean, that's what's happening. That's basically your X and your Y, or your input and your output. So F of T is your output value, so that means I have 47 equals A, which I don't know, times B, which I don't know, to the T power, which is 2. That's one equation. My second equation is going to start with 2602. That's equal to A, which I don't know, times B, which I don't know, to the T power, which is 20. There are my two equations. That is all it asked me for, so that is all I'm writing. If I can do other things, great. Nobody cares. They didn't ask you for that. And if you do anything else and you do it incorrectly, that could be really bad for you. So remember, your FRQs are worth 6 points apiece. 6 points. This, I can guarantee you, something very, very similar to this will be one of your FRQs, and this will be worth one of your 6 points. And I say very, very similar because it might not be exponential. It could be exponential, it could be quadratic, it could be cubic, it could be quartic, it could be logarithmic, it could be any of the ones that we talk about. But they're going to give you this part, and they're going to give you enough information to come up with whatever it is you need. And they're going to tell you to write 2 equations, which means you just substitute it in and you stop. Are we all capable of that? We are. I really think we can all get at least 1 point on this question. The bad things that happened were then some people went way farther. And if you go farther and things don't work out for you, then you're not getting any credit for it. You write it, you stop. Okay. The second part to that question will be find A and B, or A, B, and C, or whatever it is for that particular regression that you're doing. But now we want to find it. Now, the key words here in this sentence to me is that we're going to write 2 equations that can be used. I can use those to find what I need. I could then do some math with these equations and find that out. But just because I wrote them and they asked me for them doesn't mean that's how I have to find A and B. This would be on a calculator section. So now we're going to go to Desmos and we're going to add a table because we are doing regression here. And then we are going to put in 2, and then I want y'all to look up here real quick. I did 2 enter. When I do 20 and I hit enter, do you see how 38 popped up right there? I have no interest in 38, but it's assuming I'm going to, add 18 every time. So just be very careful that if you're hitting enter and a random number pops up there, that you take it back out or you just don't hit enter or whatever, so you're not getting other random stuff in there you didn't realize. Okay. What's our problem here? You do what? It's loading. Okay. All right. And then, so let me finish this up then. We get 47 and 2602. Uh-huh. Okay. It gave you, you're in trouble thing? Yeah. But what does it say there? It's a new one. The exception unknown. Oh. Okay. Click OK. It should let you back in. And we'll see. And then I'll get a little note that you exited early, but it's okay because you told me. Be all fine. All right. Yes. Same thing? Okay. All right. I got you. Did you have the little, it just exited it out and then you had the little thing with the red X, or did it tell you you were swiping? You said you were swiping. Do you have any idea what you actually did? No, I mean, do you feel like you swiped anything? You did. Okay. Were you just like swiping on your mouse? Okay. I don't know why that's bad, but that's why I'm trying to figure out like what's happening. Why that's bad, have no idea, but okay. You're good. All right, so I'm going to hit my little magnifying glass. So I get that. Hit regression. Now this makes a beautiful linear regression, but you can make a linear regression with, make a line with any 2 points. This is not what I want. What kind of regression do I actually want? Exponential, because it even said those words if we're confused about things. Exponential. Okay, and then double check. Okay, then once they give me this, if what I see here and here, if I see at least 3 decimal places in every number that I need, then I don't need to do anything else. Now, did this ask me for an equation? It did not. My instructions, which would probably be written a little bit better on the real thing, but it basically is just going to tell you find A and B. So that's what I'm going to write down. I'm going to write down that A equals whatever it was, 30.089, and B is 1.2498. So make sure that you are answering the question that's being asked. Don't write an equation here when you weren't asked for an equation. This is 2 out of 6 points on an FRQ. That is huge, all right? So whatever the regression is, if you can write these equations, even if you can't write these equations, you can still do this part, right? You put your information in, you find whatever regression it is, and you write down whatever the letters are, okay? It's literally that easy, right? We good on those? Okay. So then let's look at the next part. It says selected values of the exponential function g are shown in the table above. And again, I'm going to either box or circle or whatever my generic things so I can find it easily. So there's no story behind this, but it just says use the given data, again, to write 2 equations that can be used. Right? I'm just writing the equations. Now, I don't have to dig the numbers out of a word problem, but it is in a table that is horizontal instead of vertical. I mean, and I think that you're probably capable of taking the information out just fine, but it also would not hurt for you to actually write it out in ordered pairs so you don't do anything weird. I mean, that's up to you. This is not something that you would have to do. I mean, one of the, ooh, see, about to write the wrong thing. One of the drawbacks of this is if I write the numbers down wrong, which clearly I was about to do, that could be a problem. But that might help you get them in the table correctly so you don't do anything weird. I mean, it is what it is. So go ahead and you write your two equations. You don't need the computer for that. Just write in the equations. And then check yourself. Do we agree with those? If the answer is yes, you just got 1 point on your FRQ. Okay. Now we're going to find the values, which means that we are going to go to Desmos. I'm just going to X all this out and start from scratch here. And I have 3 and 8. And always double check everything after you have typed it in to make sure you didn't hit the wrong thing or your computer, see, or you didn't hit enter like I just didn't. Oh my gosh. 21.54 and 3 point. Sorry, I've gotten a little bit faster on this thing, but not really. All right, so then, now on the last one, I didn't even actually look at the graph. I didn't care about it, but I can still, make it look decent here. Do my regression. I've got exponential regression. And I have an equation. Now, this right here, I see 3 decimal places. Here, I do not. And it's possible that it's just exactly 0.7. But remember that even though Desmos and College Board are working very closely to make sure that this is going to work exactly like everything that we need, they are still two completely separate entities. And there's a lot of problems behind the equations they actually give us when we start to use them, but we'll talk about that later. Hopefully it won't be a problem by the time we get there. But how many decimal places you see and things like that too, that's just not something that Desmos has ever really had to worry about before. But if you don't see 3, then right here next to whatever regression you did, these little 3 dots, we're going to click that and then export as custom regression. And then not only does it give you that, it literally just gives you A and B. So it'd be hard to even mix those up. Okay? It gives them to you and see it wasn't 0.7. It was 0.6999991. So now I have what I can write down over here, and A equals 62.8012 and B is equal to 0.6999. What questions do you have? Anything? All right. And flip it over.
Bluetooth pairing. Bluetooth connected.
We are going to talk about some exponentials that have an E in them. So E is not brand new to you. I know you talk about it a lot in Algebra 2. I think it's introduced to you in Algebra 1, maybe, not real sure. But I'm going to show you a quick video. It's like a minute and a half that kind of explains E.
We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045 and so on. And it was first defined by Jacob Bernoulli, but later Leonard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So, if you stick $1 into a bank account with 100% interest rate compounded annually, you'll get $2 at the end of the year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then they'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
Okay, so that's the basics about E there. And one place I know that you have used it, the reason you're probably introduced to it in the first place, is for what we call your PERT formulas, A equals P times E to the RT. When you're talking about interest rates or, continuously compounding interest, your principal amount, and then your rate and your time, or what we call the PERT formula. So that has definitely not brand new to you. Now, it's helpful to know that pi is about 3.14, right? It's a little bit more than 3. It's also helpful to know, so E is about 2.718, blah, blah, blah. But just knowing it's about 2.7, sometimes that helps with reasonableness of an answer or whatever, but it's not like you have to have it memorized or anything. And here's how it's going to be presented to us. So on example 4, it says the number of bacteria B in a particular culture can be modeled by the exponential function, and then it gives me an entire function this time, where T is measured in hours, okay? Then it goes on to say, let A of T be equal to A times B to the T. That's your general form right there. It's an equivalent expression for B of T. Find the value of B. So if I need to find the value of B when it looks like this. So this is what we did. This is some of what we did yesterday during that warm-up, where we took it in one form, put it in the general form. So I'm going to rewrite B of T. That is equal to 17 times e to the 0.31 t power. Okay? Now, I know that's not in general form or in this form right here because the exponent is just a plain old t, where we have something else going on in the exponent. So what I can do to rewrite this, I can rewrite this as 17 times e to the 0.31 to the t power, right? We're just undoing that power to a power rule like we have on the other equivalent forms. Now, it's different as to where, like, I don't have like 2 to the 5th or something like that, but this actually makes it easier because if I had 2 to the 5th, I'd have to know that that is 32. E to the 0.31 power is e to the 0.31 power. Like, it is what it is. And so what I have here is, this is A, this in the parentheses is B, and then my t is up there. So that means that B is equal to e to the 0.31 power. So what's inside the parentheses is your B value. And that's just understanding the equivalent forms and how to manipulate your exponents, right? That's basically what they're testing there. And this is on a calculator portion. Just because a question is on the calculator part of either the multiple choice or the free response doesn't mean that you'll even touch the calculator. Doesn't mean that you have to have it. Also doesn't mean that using it would help you any, because I don't see how the calculator would have helped you any on that. Like, it just wouldn't. And that's going to happen. Okay. So then the next part says, find the average rate of change of B of t. What does average rate of change mean? Yes. It closed. Okay. You're good. Means slope, right? Let me start keeping a track. Give me more on here. Average rate of change is what? Slope. Yes. All we have to do is find the slope. Okay. So we're going to find the slope. And to do that, I have to have an interval. So I'm going from 1 to 7. So I know that slope is the change in y over the change in x. And just like the first step, every time we do slope, whether it's calculator or non-calculator, we set it up. We write the difference quotient. This is y over x, so b of t over t. So that means this is going to be b of 7 minus b of 1 over 7 minus 1. Okay? And I have done my best to force you to write something like that every single time that you have done slope. right? Because that is necessary. That is showing the process. That is showing big boy and girl math and not just random numbers that y'all like to write down sometimes. Now, if this was a non-calculator section, we'd go off to the side and find B of 7 and B of 1, but it's not a non-calculator, it's calculator, so we're going to let the calculator do everything. So we're going to come back over here, and we're going to X this stuff out, and then we are going to type in this equation right here, which is also this one. It's easier for you to read on yours, whatever. We're going to type it in just like it looks. B of t equals 17 times e, and really you can just do just the lowercase e, it'll know what you're doing, to the 0.31 t power, okay? What's the question? Yours, Mark's? Oh. If it's a warning, you're fine. You just click OK, and then, did you feel like you swiped on anything? No? Okay, so yeah, that's probably why. So it must have something to do with your keypad. That's why I'm just trying to figure out like why it's even happening, because I don't know. That's fine, you're good. All right, so we type that in, we get something like this, and I can't see the whole thing. I don't know that I even care at this point, because the other two, we weren't even looking at the graph, right? But one nice thing, because you may have been told, and I think it's true for the star version of this calculator, that you have to use X and Y, you don't get to use B, T, and those other things. But we can. The fact that we can is huge because we couldn't on the Inspires. We had to do everything in terms of X and Y and F of X, which I think kind of contributes to the problem sometimes of y'all writing everything as F of X. If we're able to actually use the variables that are in our question, that will hopefully help us actually do it correctly. That's my goal. That's my hope. All right, so then now that we have that in there, now we're going to go and type this in exactly like we see it. So we're going to go back over here. I like to start, I hit the divide sign first so I get a fraction. And then we're going to do B of 7 minus B of 1. Oop, that's just a 1. Ay. Okay. Let's go to the wrong thing. All right, B of 1. There we go. That's a 10. Oh my gosh. Over 7 minus 1. And then, bam, there's your answer right there. Okay? So we're not going off and evaluating things and substituting them back in. It just does it all for us. But we do have to have this set up here, right? This is showing your process, not just some random number written down here. So this is 20.9521. Then we need units. And you don't need to overthink your units. To get that number, we literally put y values over x values. So look back into or output over input, look back in the question, and your output, which is B of t, what does B of t represent? Or what are my units? Bacteria. So bacteria, and the t represents what? Hours. So bacteria per hour. And it's possible that you write down units that don't make any sense to you at all. That's okay. Sometimes when we write them down, we're like, I don't even know what the heck that means, but it is what it is. Okay? We good? We don't have to overthink it or anything. Any questions? Okay. So then this next one says, find the number of bacteria predicted by the model after 15 hours. So they have given us 15 hours, which means they gave us T. Right? So we want to predict the output when the input is 15. So one of the things that we have done before, when we were doing some regression stuff, was just to go in and graph that vertical line so that we could see where they intersect. So if we go here and we type in t equals 15, t equals 15, oop, that's a 5, my God, what is wrong with me? 15. Press harder. Then I need to be able to see when my input of 15, but even though I can't see my function, I don't see a vertical line here, okay? So one thing I have found when you get to use all these variables is that for whatever reason, when it's a vertical line, it doesn't like it, okay? But that's okay, because we were going to do this differently anyway. I just wanted to show you that, because that's kind of how we have to do it on some of the regression stuff, because using the actual equation is problematic. Plus, that's pretty simple. But if I have typed in the equation, I'm in control of that. I typed in the equation. I called it b of t, right? Since I have over here that what we have is t, and that means that I want b of 15. I'm basically just evaluating the function when t is 15. Would you agree with that? And that's how I write it in function notation. So then if I go back over here, I can type in b of 15, and it will give me my answer. Yes, sir. You can, but I would not suggest you change variables in the middle of this. That would be bad, bad, real bad. Plus, if that's the only way you know how to do it, then you're not going to be able to do that. So this is really the more function way that you should be doing it. Okay, we good with that? So then we come back over here to write down our answer. B of 15 equals 1777.9447. And what are the units on this? Hours? Bacteria? Is this an input or an output? Output. So this is my bacteria. So when we're thinking about so my ordered pair is T, B of T, right? So my units then are input is hours, output is bacteria. And I'm going to run out of room, but you get the idea, okay? So it might help to write yourself something like that too, just to keep everything straight. All right, then it says, at what time will the number of bacteria be 1,000? So they're giving me the outputs, right? They're telling me this is equal to B of T. B of T equals 1,000. That's what I know, and I want to figure out what the time is, so T equals something. So if I go back to Desmos, and over here, I'm going to type in, write what I just wrote, which is B of T equals 1,000. Which then gives me like an error here and here, but I don't care because I already used them, so it really doesn't matter. And I have, oops. So I have this. Well, I don't see anything happening over here, but it could be that it's not working like the other one, or it could be that I just can't see it in this view. If B of T is 1,000, that represents my output, right, which is my Y values. So I need to be able to at least see when Y is 1,000. You can make that happen, however. Apparently mine is not cooperating like it has been. There we go. There we go. Let's try to make it even smaller. I couldn't. All right, and notice that they're both blue. Okay, so you can mess with the colors, meaning that first of all, I can turn this off and on, but if I press and hold, I'm sure you know these things, I'm just making sure. Let's change that to red. So now I know the difference between the two, because sometimes they graph them with the same colors. But this horizontal line is my 1,000. This is my function. So this is the Y value of 1,000 right there where they intersect. That gives me the X value that I'm looking for. Okay. One new part, because I think things are changing literally every day with this. Another new thing that we have is this little box over here right to the right of the ordered pairs. Because one of the things that Desmos is lacking is the ability to store numbers. I think that's kind of where we're going with this. But if you click on that little box there, it just exports the ordered pair over there. I'm not sure why exactly you would need that, except that because this stays up here. But I guess if you had to move your graph again and you couldn't see it, you could keep the point there. So not sure why we would need that yet, but I have a feeling we will. So just want to tell you where it is. So that means I can come over here and say T equals 13.1436. And what are my units? Hours. Okay. What questions do you have? We good? All right. Look at this last one. After 50 deer were introduced to a large wooded area, so we got 50 deer being introduced to a large wooded area. Population of the deer in the wooded area can be modeled by this function, which is in general form, where T represents the number of years since the deer first introduced, and the population of the deer increases by 13% each year. So we've been writing these equations by finding two equations using two ordered pairs. I don't think there's enough information up here for two ordered pairs. Could we get at least one ordered pair out of this information, you think? What would that ordered pair look like? First of all, is this 50 deer, is this an input or an output? Output. Because first of all, it tells me a whole lot of stuff, plus when I'm looking at this, T is the input, D is the output. So we have T, D of T, right? And so if I have a number of deer, which is 50, that's my output. What is the input when the output is 50? 0, because that's when they're introduced, right? So I have one ordered pair. There's not enough, they didn't tell me another ordered pair there. So I've got a couple of options here. Another way to do this is if we know A and B, then we can just write the equation. Well, this is A, and that's my initial amount. If you don't recognize it as that, that's okay, because you could still set up an equation and say that 50 is equal to A, which we don't know, times B, which we don't know, to the 0 power. Then B to the 0 power is 1, so you end up with 50 equals A. And it just occurred to me, I don't even think I read the question here, but it says find the values of A and B. It didn't say to write two equations here. It just says do whatever you got to do to find A and B. Well, there's A, okay? B is the common ratio, and that probably has something to do with this 13% each year. So do you think B is 13%? No, okay? Because it's going to increase by 13%, right? So I can't just multiply by 13% because that's going to give me something less than 50, right? You can look at this by using another equation as well. We could say, like, I know my initial amount is 50 times B that I don't know to the first power. Like, what would that be after year 1? We know what it is in 0, right? So then what would I have to multiply 50 by to get my next year's value? I'd have to multiply 50 by what? 1.13, right? Because next year we will have 113% of the amount of deer that we have this year. Okay, so it's not just 0.13, it's 1.13. And so then that basically tells you that that's your B. Or you can just take it from an understanding of this, and your B is equal to 1.13. That's the way that exponential functions work. So then we're supposed to write the equation. So D of T is equal to 50 times 1.13 to the T power. All right, so here's a beautiful way that the AP exam is graded, just in case you were not aware. Is that, so let's say that this is 1 point, one of my 6 points. And then the next thing we're going to do, which we're going to have to use that's going to be a second one of my points, one of my 6 points. If this is wrong, and I have to use this for the rest of my stuff, I really have no hope of getting the same answer that's on the answer key, right? I mean, it's over. But it's not over for your scoring. Because if this is wrong, then you don't get this point. But if you use your wrong equation correctly here, you will still get credit for this question, okay? That's why these, when they're being scored, they're called readings. The grader reads with you. So if you don't get this point because this is incorrect, they're going to use whatever equation you have to move forward and then give you, if you used your wrong equation correctly, you're good. So we know it's supposed to be an exponential equation. If you can't figure out what part of it is, make something up, all right? That when, will you get this point? No, but you weren't going to get it anyway. You know, just put 50 times, I don't know, 2 to the T power because you have no clue what's going on. You won't get this point. You use that right here correctly, you would get this point. Does that make sense to you? So don't give up and don't leave anything blank. I say that, and some of y'all are still leaving multiple choice questions blank. That really makes me want to scream. What is wrong with you? Pick your favorite letter if you can run out of time. Okay, put something. All right, so then let's look at this next part. It says, according to the model, so again, according to the model in part A, it doesn't say according to the right answer from part A. According to the model from part A, what is the population of the deer in a large wooded area after 6 years? And so that is my T. So again, we are looking for, we're just evaluating that, D of 6. So I'm going to go over here, I'm going to X all this stuff out that I got going on. And then let's type in our d of t. D of t. Ooh, well, those are actually right there. Okay. So d of t equals 50 times 1.13 to the t power. Okay? And maybe I'll care about the graph, maybe, yes, sir. Just the warning or you're out? The warning. If you're warning, you're fine. Same thing? You got the warning too? Okay. If it's the warning, you keep on going. Just let me know if it shuts you out. And then, again, I'm going to see if I can figure out what exactly is happening. So I got that. Now I just want d of 6. Okay. And then, boom, there's my answer. Okay, so I'm going to go over here. And d of 6 is 104.0975. And what are my units? Deer. Can I have part of a deer? No. But it doesn't tell me to round to the nearest deer or anything, so leaving an answer like that would be okay. Okay, taking the liberty of just going ahead and making 104 deer. I mean, if you have this and then you want to write 104 deer over here, but I wouldn't unless it says to the nearest deer or something like that. But I do want to tell you about, like, if, let's say that you didn't make up an equation. You really thought you were 100% right. And let's say your equation, you put in just 0.13 instead of 1.13. When you do this one, and you go to write down your answer, and you have 0.00024, whatever, and you go to put your units on there, which is deer, something should catch your attention like, that don't make sense. Because we're increasing every year. It's been 6 years. I don't know how it went from 50 to like a microscopic part of a deer. So that, if you think about reasonableness of an answer, if you thought you were right, that might trigger something to go, wait, let me go back and see if maybe I can figure out what I did wrong here. Okay? But if you already knew you were wrong because you just threw something down, then you just go with it. Put your label on it, move on. And if you're running out of time, go, well, I don't know. I think I did this part right. I guess I did that wrong. At least I could get 1 point, and you just go with it. Okay? But don't not write it down because it seems weird. Okay? All right. So then the last part says, find an equivalent expression for d of t, where t is measured in months instead of years. So I write down d of t equals, and we had 50 times 1.13 to the t power, right? Well, that's because this is the percent change in years, right? And it's telling me we're changing it instead of years. It is supposed to be months. How many months are in a year? 12, okay? So I'm going to take the year, which is t, and I'm going to divide it into 12 months. And I know on questions like this, some of you second guess yourself, because sometimes you might multiply by the 12, sometimes you might divide, it depends on the question. But just ask yourself, once you do that, all right, if this is in terms of years, if I substituted in 1 month, that would give me 1/12 of a year. That makes sense. If I substituted in 12 months, that would give me 1 year. That makes sense. Whereas if you wrote 12t, then, and you said, okay, I'm going to substitute in 1 month, that gives me 12 years. That makes no sense. Okay, so at least you can think through it that way. All right, questions? We good? All right, go.